Hello everyone, my name is Pyarasani Bharat from IT section. Today I am going to discuss about quadratic form nature identification for optimizing energy absorption in crashworthy structures. Definition: quadratic form nature identification refers to mathematical process of determining whether a quadratic expression or matrix associated form is positive semi-defined, negative defined, negative semi-defined, or indefinite. In the context of crust-worthy structures, this identification is used to classify the behavior of structural energy functions such as strain energy or stiffness response to evaluate whether a design configuration promotes stable deformation and optimal energy absorptions during impact. Introduction: crustworthy structures are engineered to manage and dissipate kinetic energy during impact event, thereby reducing the forces transmits to occupant and critical components. The optimization of energy absorption is in such structures requires a reliable mathematical framework com- capable of characterizing deformation, response, and stability behavior. Applications: structural, structural crustworthiness and impact design. Quadratic forms are used to analyze strain energy and stiffness matrices to determine whether structural deformation will be stable, controllable, and capable of maximizing energy absorption during crusts. Finite element analysis. The nature of quadratic forms helps access elements, stability, convergence, behaviors, and validity of stiffness matrices in simulation of automotive, aerospace, and civil structures. Vari- vis- Vibrations and model analysis. Optimizing lightweight materials and top- topologies. Mathematical stability and bulking predictions. Control systems and robotics. Machine learning and data classification. Quadratic decision boundaries appears in support vector machines. Discriminate analysis and optimization algorithms used for promote rec- recognition. Dynamics and energy conservation studies. Quadratic forms describes kinetic and potential expressions in multi-body dynamics, enabling accurate modeling of motion and impact responses. Material science and elastic theory, strain, stress strain relation, and constitutive models employ quadratic form to determine whether materials behave stably under load. Physics and quantum mechanics. Quadratic forms appears in Hamilton eigenvalue problems and energy state classifications. Properties of quadratic form. Symmetry of associated matrix. Every quadratic form f of x is q of x is equal to x power t into a into x corresponds to a symmetric matrix A, which allows constraint evaluation of defining definitions depends on eigenvalues. The nature of quadratic form is determined by the eigenvalues of its associated matrix. All positive positive definite, all non-positive positive definite, semi-definite, all negative negative definite, mixed signs, indefinite. Basic invariance of definiteness. The definiteness clarification of quadratic form remains unchanged under orthogonal change of basic making in orthogonal change of basic making it independent of coordinate system. Testability via principal minus. Leading the principal minus provide an algo, algebraic methods to determine definiteness without computing eigenvalues. Homogeneous homogeneity of degree 2. Quadratic forms satisfy q of lambda x is equal to lambda square into q of x, m- meaning the value scales with the square of its input magnitude. Convexive relationship. Positive definite quadratic forms are strictly convex. Positive semi-definite forms are convex. This property is widely used in optimization, energy interpretation in engineering. Posi- Positive definiteness corresponds to physically meaningful and stable energy storage. Example, strain energy. Sign structure indicates stability, definiteness, stable response, indefiniteness, unstable or deviant behavior. Diagonalize possibilities. Through orthogonal transformation, any quadratic form can be expressed as a sum of squared terms, simplifying interpretation, non-negative and bounding behavior. Quadratic forms define quadratic forms define whether a system has a low energy bound critical for mechanical and dynamic stability. Problem statements. Crashworthy structures are required to absorb maximum impact energy while minimizing structural failures and occupancy injuries. However, predicting and optimizing the deformation behavior and energy absorption capacity of such characters remains challenging due to nonlinear material response, complex geometry, and various loading conditions. The mathematical characterization of strain, energy, and stiffness functions using quadratic forms offers a potential pathway to classify deformation stability. Yet the nature of these quadratic forms is not routinely integrated into crashworthiness design evaluation. This gap limits the ability of engineers to accurately determine whether a given structural configuration will yield stable energy absorption, permanent bulking, or ineffective collapsing. Uses of quadratic form. Natural Natural identification. Stability assessment. Energy absorption evaluation. Classification of structural response used to distinguish between safe deformation, bulking, tendency, collapse modes. Optimization and design improvement. Validation of stiffness and mass matrices. Vibration and modal safety. Control system stability. Machine learning decision boundaries. Energy representation in physics. Material behavior and elasticity. Conclusion. Quadratic form nature identifies plays a vital role in analyzing and optimizing the energy absorption preference of crashworthy structures by determining whether the associated structural energy expressions are positive, definite or indefinite. Engineers gain insight into deformation, stability, low transfer efficiency, and impact response behavior. This mathematical framework enables the prediction of safe deformation modes, prevention of structural instability, and enhancement of crash energy management through informed materials structure selection, geometry refinement, and design optimization. As a result, quadratic forms evaluate servers as functional analytical tools that support the development of safer, lighter, and more reliable structures in automotive, aerospace, and transportation applications. These are the references. Thank you.